Good morning, students. The topic we are going to discuss is circular linked list. Circular linked list is very similar to singly linked list. Then what is the difference between singly linked list and the circular linked list means? In the singly linked list, the next part of last node is always null. Whereas in circular linked list, the last node contains a pointer to the first node of the list. Okay, the last node of the linked list contains a pointer to the first element of the list. The last node always points to the first node. That's why it's called as circular linked list. So we have two types of circular linked list: circular singly linked list and circular doubly linked list. How the circular linked list is represented in memory? So here each location consists of data part and next part. Okay, as like as the singly linked list, you can traverse the elements. Since the start pointer points to the location 1, so this is my first node, so which contains the data height, and my next data is available at location 4. From that I can get my next data, it is E. Then move to the location 7, get the third data, it is L. Then we have to move to the location 8 in order to fetch the fourth data, it is also L. And my next data is available at the location 10, it is O. And we follow the next pointer. So the next pointer points to the initial node. Okay, it contains the address of the first node. So this is called circular linked list, and we get the data hello while traversing this circular linked list. So how the new node is inserted in a circular linked list? We have two cases. Either the node can be inserted at the beginning of the circular linked list, or the new node can be inserted at the end of the circular linked list. Okay, so insertion in an empty list. So we don't have any elements in the list. This is my first node. Okay, so new node is pointed by the pointer called new, and I assigned some data value to the new node. Since this is my first node, rear is pointing to the new node, and rear of next is again a pointer to itself. Okay, this is my first and last node, so the next pointer points to that node itself. So this is the insertion of an empty list. If I want to insert the new node at the beginning of the circular linked list, okay, what is the code we need? So consider this is my circular linked list. I want to add the new node into the already existing circular linked list. So already existing circular linked list is shown by the dotted lines, and I want to insert the new node with the data 10. Okay. Initially I have to allocate the memory, I have to initialize the data part to 10. So what I need to do means, the rear pointer points to the last node of the circular linked list. So rear of next now points to the new node. Okay, rear of next points to the new node. That is, new node of next is equal to rear of next. It can also be written as new node of next is equal to current pointer. And you have to make one more pointer change, that is, previous of next is equal to new. Okay, previous of next is equal to new. That is nothing but rear of next is equal to new. Okay, in order to insert the element at the beginning of the circular linked list, you have to create the new node, and the new node next is the first node, that is the node pointed by the variable current, the current node. Okay, the new node of next is equal to current node. So you can rewrite it as new node of next is equal to rear of next. Rear is a pointer which points to the last node of the circular linked list. So rear of next contains the address of the first node. So you can use any of these forms, and you have to make one more change. After the insertion, the rear node should not point to the previous current node, it should point to the new node. So you have to make the previous of next, that is rear of next, is equal to new. Okay, this is what happening when we insert the new node at the beginning of the circular linked list. So if I want to insert the new node at the end of the circular linked list, so again the same convention, the dotted line shows our circular linked list. Okay, in that circular linked list, I am going to add the new node with the data 70. Okay, after insertion, what are all the changes? What are the changes are there? So listen, my current node is 10 and my rear end is 55. Okay, my new node is 17. I am inserting the node 17, okay, after the rear end. So how we make a pointer changes? New node of next is equal to rear of next. Okay, new node of next is equal to rear of next. That is, it is pointing to the first node, or you can write it as new node of next is equal to current node. Okay, this is the first thing we have to make. Similarly, you have to make with one more pointer change. Previous of next is now new node. Okay, that is rear of next is new node, and after the insertion, the node 70 becomes the rear end. So you have to make a rear as new. Okay, so once again I am telling, to insert the new node at the end of the circular linked list, we need 3 pointers: current, new, rear, okay, and previous. These are the pointers we need. The current pointer points to the first node, the new node points to the new node which is going to be inserted, and the previous node points to the last node. Similarly, the rear also points to the last node. Okay. So after insertion, before insertion, 10 is my first node and 55 is my last node. So it is pointed by rear. But after insertion, the node with the data 70 becomes the rear node and it is the last node. That node should point to the first node. So what are the changes I need to do? New node of next is current node. Okay. So the first pointer change. Okay. Then how we link the last node of before insertion with the new node? Previous of next is new node. Okay, previous of next is new node. And after insertion, the new node becomes the rear node. So rear is equal to new. So that's about the insertion of a new node at the end of the linked list. Similarly, for deletion also we have two cases. If I want to delete the first node, okay, so if the first node is deleted, then what happen? The rear of next, that is the last node of next, is equal to current node of next. 10 is deleted. Okay, the node with the data 10 is deleted. So that is the current node, and you have to make a pointer change such that previous of next, that is rear of next, is equal to current of next. Then you can use the function delete to reclaim the space. Similarly, if I want to delete the node at the end of the circular linked list means, see the diagram. So now the current node and the rear node both points to the last node. That is the node I am going to be deleted. So after deletion, okay, what happened? Previous of next is equal to current of next. Before deleting the element, I have to get it next at next pointer. So that's why it's stored in previous of next is equal to current of next. After storing the value, you can delete the current node. After the deletion, the previous node becomes the rear node. Okay. So that's about the circular linked list. So just I am telling one more time. If I want to insert the new node at the head of the circular linked list means, okay, so we have to make two pointer changes. So what are they? The next pointer of new node is pointing to the first node. Okay, the next pointer of new node is pointing to the current node, and the last pointer, the last node's next pointer points to the new node. Okay, the last node's next pointer points to the new node. Similarly, if I want to insert the new node at the end of the circular linked list means, we have to make three pointer changes. One is, after insertion, the next part of new node becomes the current node, and the next part of previous node points to the new node, and after insertion, the new node becomes the rear node. Okay. So similarly, for deletion, if I have deleted the first node from the circular linked list, then what happened? You must make the pointer change of last node. Okay, the last node next pointer points to the current node's next pointer. Okay, then you can delete the current node. Similarly, if you want to delete the node from the end of the circular linked list, then what are the changes we need to do? After deletion, the last node will not be there. Okay, so previous of next is now current of next. After getting the pointer value, you can delete the node 17. After deletion, my last node is now node with the data 55. Okay, node with the data 70 gets deleted. Node with the data 55 is my last element. So rear becomes the last node. 55 becomes as the last node, that is the rear end. Okay. So thank you all.